Welcome to Graph Power Hour. Hi, my name is Paco, and this is Graph Power Hour from Senzing. Today, we're really thrilled. I'm delighted to get to introduce Claire Longo, who is AI lead researcher and mathematician. She's a researcher at Comet AI. We'll be talking about Comet and especially about Opik, an observability and optimization platform. Claire, welcome, and I bring you on stage here, and also just want to introduce you, I'll let you give some of your background about how you got here, what you're working on.
Yeah, thanks, Paco. Wonderful to be here. Hi, my name is Claire Longo. I am an AI researcher and developer advocate at Comet. We are building Opik, which is the open source tool for observability and optimization. I'll talk a little bit more about that. But yeah, how did I end up here? Well, I started my career as a mathematician, but I moved through the kind of different waves of hype in the Silicon Valley. I came through the big data wave and then the data science wave, and now in the AI phase of life. So my career has been kind of following those tracks. I've been an engineering manager at Twilio and Opendoor, kind of the bigger enterprises, and then decided to go into the startup world. So I've worked for Arise and now Comet, and just really enjoying like the fast pace of just building new stuff on this frontier of AI. So that's a little bit about my background. I'm very passionate about observability specifically because I myself have put models into production. I've seen things go really well and really wrong. And so that kind of inspired me to dive into tools like Opik.
Oh, fantastic. So to give some background then on Opik, there's a platform you can run microservice out of a Docker container and collect observations about an LLM integration. And also you can do more. I mean, it's not just the integration, but that is a lot of the focus.
Yeah, absolutely. You described it really well. It's an open source tool, so it's free. Everyone can use it today. And its real purpose is to give you a tool that's going to follow you through every phase of development of your application. I know we start in like the tinkering phase. Maybe we're experimenting with different models, different prompts. And at that point, we need a baseline data set. Maybe we're fine tuning stuff. We just need to measure what good looks like. And then once we figure that out, then we're going to production. And that's where we need visibility. We don't want it to be a black box. So this is a tool that's going to allow you to trace all the inputs and outputs every step throughout your LLM application end to end, as well as place eval metrics along the way and on the system overall. And there's an art to eval metrics. I'll get all into that. It's a really interesting area. But then the final piece of that picture is the feedback loop. So we can measure things, we have visibility into our application. But how do we actually improve it? So that's where the optimization comes in, as well as collecting feedback loop data.
Oh, fantastic. For the observability part where people are capturing measures, what types of variables, parameters, measures are you seeing typical?
Oh, I love that question. I'm seeing everything. I've actually got to be in a really fun role at Comet before I moved into my current role as developer advocate. I used to lead customer success. And so I got to see like all these different projects and some really incredible customers, like great logos that we've worked with in the past and currently do. It was just such a great like growth opportunity, like selfishly for myself too. I was helping our customers, but also like I learned so much because I saw these other projects. So I got a window into all the different metrics that people needed to measure for these different kinds of LLMs. And the trends I saw is there's really a few categories here. The first category is like the obvious stuff that LLMs do wrong. They hallucinate. They might go off the rails. We've all seen the news articles about the fairness and bias issues, things like that. So there's some really like out of the box metrics that you should just like always have. And then there's this other category of like simple heuristics, business rules, maybe like if you're asking something to produce SQL or like JSON, like that's a very simple, like, is it or is it not? Does it violate this rule? And then the third category is the most creative. It's custom metrics. And that's where the concept of like LLM as a judge comes in, where you can really create your own metric to maybe measure something that we couldn't really measure before, but might be really specific to your business use case. So I have a few slides I can like dive into like those different categories a little bit more in depth, but those are kind of the three categories of metrics that I've seen.
Oh, great. Well, and actually that's a really interesting aside, totally off topic, but I work in dev advocacy as well. And what you're mentioning about sort of going from customer success to DevRel, and I've experienced the opposite direction as well, or at least the two go well together, because I do get kind of pushed into more of like a customer success role sometimes. So it's really interesting to see flip sides of the same coin. Yeah, no, let's go into your slides. That's great.
Okay, let me pull some slides up here. I don't like to do death by PowerPoint. I'm really just trying to illustrate a few concepts, but I want to keep it an open conversation with us and the audience here. But the first thing that's been like really top of mind for me, not just within Comment and working with Opik, but throughout my entire career, one thing that's been top of mind is like, what is that development workflow for an AI application or a machine learning application? And I look at it in kind of three categories. I think there's a lot of semantics around this. You can relabel these categories with different words, but generally there's kind of three steps and we're kind of doing the same thing within them. So the first one is development. I've also heard it as experimentation or even R&D, but that's where I've got a cool idea and I'm putting together a prototype. I might be working by myself. I might be working with just a few other folks, but I'm typically like locally on my own machine. I might be in a Jupyter notebook and I'm just tinkering. I'm just trying to bring something to life. This is really like the draft stage. And this is where there's a lot of iteration. So I might be iterating on the prompt. I might be trying to figure out what model type I should use. Should I fine tune? Should I not? A lot of questions in this phase. And so this is the phase where experimentation, I think, is critical. And Opik is a tool that's going to facilitate a lot of experimentation. As someone with a statistics background, I'm really passionate about true statistical, like scientific experimentation. I've seen a lot of projects in my life where people maybe just tweak a few things and look at a few examples and ship it because it looked good. I've even done it myself, especially it's like tempting in this phase of experimentation. Like maybe I just want to like type a few things into the system. Comes out, it looks like what I want to see. Okay, we're ready to ship it. But it's just not going to scale in production. So the concept of like a true baseline data set can be important here, but it's actually quite nuanced because that baseline data set needs to represent the data you're going to see in production when your app goes forward. And that's actually really hard to do. So there's a lot of nuances to like truly testing these systems, but I think the main theme is we need it to be reproducible. If I run a actual experiment, I want to be able to share it with my peer and have them actually be able to reproduce the results I got before we move forward with the project, and also just have a record of what we tried, what worked, what didn't work. So that's where Opik really comes in, is facilitating that iteration as well as that collaboration there.
Oh, fantastic. I mean, the reproducibility is so important because, as you're mentioning, it's really counterintuitive sometimes. You might be working on a problem and you're working with a particular model, and then you're seeing a certain rate of token usage, but then you take the hit and go to a larger model, and maybe there's even less latency and less token usage. These things happen. So unless you're really measuring it, it's very hard to determine how it's going to work.
Yeah. And that's a great example of like a result that maybe people wouldn't believe me unless they can reproduce. You need that experiment management component there. The next phase is testing. This is, I think, very familiar to anyone coming from a software background. Something I had to learn a little bit more about because I was coming more from the math and stats background. But this is like CI/CD, unit tests, those kind of things. I think that can look a little bit different when you have an LLM or even a machine learning model in the picture here, because it's a little bit harder to test. And that's where we get into concepts like really defining the metrics that you're working with. The metrics are relevant in experiments, they're relevant in tests like this. But there's this whole art to defining LLM eval metrics. And I've got another slide. I'll go deeper into that in kind of the next phase here.
Yeah, no, something that comes to mind there, we were talking previously about this, but if you dig back, and this is ancient history, if you dig back 25 years and you look at like Agile Manifesto and all that's come out of like methodology based off of fast iterations and having paired programming and working closely with stakeholders, I think what you're describing in an interesting way for AI, now this really cuts to the essence and intent of Agile, of like, what is that domain expert interested in? Can they articulate a question? And now can I measure the outcomes based on that question to iterate fast on my development? And so, that's maybe something that gets buried under a lot of methodology speak, but I think that when you're working with Opik, this is front and center.
Yeah, that's a really good point. I like the kind of illustration there with like the Agile framework, because taking like a step back from projects like this, the big picture is like, why am I building this? What is the business impact? What is the impact on my customer? And pre-LLMs, I found that very hard to measure. There were some things that were obvious to measure. Like if I'm trying to drive revenue, I can measure that directly. But in a lot of my projects, there were some outcomes, like maybe customer satisfaction. That's a good example. Like, did somebody feel good about their interaction with this chatbot? Well, it's a little bit subjective. You can have some kind of feedback loop. You can try to do sentiment analysis, but it was a little bit clunky. But what I'm seeing now with LLMs is there's a metric type called LLM as a judge. It has its flaws, which I'll talk about. It's also incredibly powerful because it's just a prompt and you can customize it. So you can start to measure things about your product, about your project, and the overall impact that it's having that weren't really measurable before. And that helps us communicate out to other teams. And it also helps me just kind of keep my project aligned as I'm building it.
Is it possible to look at this in phases where you're running your iterations, you're collecting observations, and maybe you take a pass through with a particular approach to LLM as a judge, and then maybe get some insights in that and go back and try a different pass? Like, you can also iterate on how you're collecting or how you're defining those evaluations.
Oh, like defining the LLM as a judge itself.
Yeah, it seems like that does not, in contrast to, other types of test coverage, that's a part that doesn't have to be done completely in lockstep with putting a context window out to an LLM, getting a response back.
Absolutely. Let's hop there. I think the first thing I'll say about that is I've never seen a project where before the application went to production, the team knew exactly all the metrics they should be monitoring.
Right.
Unfortunately, you see stuff in production you just didn't know were going to happen. People use your app in ways you just didn't anticipate. That's why we beta test things. That's why we want that customer feedback. And I've seen, like, even coming up with the metric suite itself that you're going to use for monitoring and experimentation, that itself is iterative. So I've seen people add metrics to that, maybe realize like, hey, we actually don't care if if it's hallucinating, that's actually value to our customers, whatever it is. So I've seen that iteration. I hopped to this slide because the LLM as a judge concept itself is interesting. And I wanted to give an overall review of what this is. When I first encountered this metric, I thought it was really weird and I had to kind of sit with it for a while. So essentially what it is you are using an LLM to judge the output of your other LLM. So let's say you built an LLM application and you want to measure something about its output. You're then sending its output to another LLM and saying, hey, take a look at this and grade it for me. I think of it as essentially the human parallel would be if I sent you some of my code and asked you to give it a review. You give it a thumbs up, thumbs down, and maybe score it from 1 to 10. So it's really having like another person review your work, but it's having a robot review the work from another robot. And it's a really good framework because what that metric is it's just a prompt. And you're asking the prompt to cast this into a number. So you can say, give me a number from 1 to 10, 0% to 100%, or binary labels, which I prefer, 0 to 1. There's a lot of discussion on whether or not these LMs can actually look at the ordinal value of numbers and if it can actually score things on a scale accurately. Personally, I don't think so. It's a language model. It's not really built for that. And I think it's an interpretation of the meaning between like 1 versus 2 is actually, I don't think that's deeply encoded in its system. So I go with binary labels, but I still think if you go with like a scale or something like that, it's not super harmful. I don't think you can really put a confidence interval on that because you're introducing like another source of uncertainty using that.
Exactly. Yeah.
So that's that's like where these things become a little bit shaky. But I think it comes down to like how we implement this. If we're using this as a directional metric, if this thing spikes really high or there's like a huge difference between this metric using one prompt versus another, that's going to indicate to me that there's something to look at. There's some kind of result here. So I wouldn't take this as like a number the way we think about numbers, but I think about it as a proxy metric that is really critical in monitoring, really critical in experimentation with LLMs, and also customizable. So now we can start to measure stuff we couldn't really measure before. So hopefully that gives like overview of like what this metric is.
Well, so following on that, if you've got this kind of proxy measure and you could do a number of them, do you see anybody treating this, instead of having an interval between 0 and 1, instead of looking at it that way, do you see people looking at this as more of like a Monte Carlo approach where there's a lot of different judges and they're throwing darts and you can kind of count like how many are on target, how many are off, and you can get the directionality probably there more reliably than introducing, like you say, this added uncertainty of the LLM judge interpreting?
100%. Your intuition is spot on. It actually exists. It's called LLMs a jury, which I think is
Oh,
kind of
okay.
interesting for that. Yeah, we
Yeah.
actually had that. My colleague Abby has done a lot of research in that concept, and she wrote a whole blog post. So maybe that's something I can send out to the group here.
Oh,
But
yeah.
it's essentially almost like an ensemble method. Like
Right.
the way I like to
Yeah.
think about that is like if I'm going to have somebody grade something or review a piece of work for me, it's actually better if I can send it to 3 people instead of one, because then I'm getting a diverse opinion. So in LLMs a jury, I actually like to send it to maybe 3 different LLMs with like different parameters. You're almost getting like a bit of a different opinion there, and then you can kind of ensemble the score. So that kind of can reduce some of the possible uncertainty there that we can't really measure.
Excellent. And okay, so we've got the observations, and we can capture those out of how you're integrating the LLM. Like for instance, I've been using Opik with DSPy, and so there's support. And I should mention, congrats to your team. I think we counted over 50 different integrations.
We have a lot
There's
of
a huge amount. So this team has been really busy and supporting what you need. And so, okay, we're capturing those observations and then getting into the measures. This is where you have more of the evaluation part of it, or would you put the evaluations later?
So let's go back to this slide. Oops, this one. We'll get to Chevy in a minute. That's a very interesting topic. So going back to the workflow. So we talked about development and testing. So I'm coming up with the metrics in these phases. I'm using them to run like hypothesis tests, true experiments. I'm also using them to maybe generally like measure business impacts that I couldn't measure before. So I come up with a great MVP. Maybe I show it to my product manager. I'm like, hey, it's going to increase our favorite metrics by XYZ, something like that. Now I've got to go to production. So the interesting thing about this kind of circular development lifecycle here is that the metrics that I tested with, experimented with, communicated out to other stakeholders outside other teams, those same metrics are going to follow me to production, because that's exactly what I want to also monitor. And so Opik is built really well to help you in all 3 of these phases. So you don't have to like switch tools. Like now you got to move to a different monitoring tool and
Right.
maybe try to replicate those same metrics, and it's not quite going to match. So being able to follow like all the way through to production and give me like a monitoring dashboard, alerts on these metrics, that's super helpful. And then I can continue to like add new metrics if I think of new ones, as well as collect data that I'm seeing in production. So I think you and I have talked a little bit about baseline data before. Whatever you tested your model offline, the data you're going to see live in production, it might not look the same. You're going to see new and unseen patterns, and that kind of like drift is so important to measure as well as correct for. So at that point, we want to be collecting those observations, feeding it back into the system so the system can learn and improve over time.
Yeah, one of the things we were discussing earlier was about having a baseline or benchmarks. We work a lot in entity resolution. It's kind of nuts because my friends and colleagues in machine learning always are like, oh, well, this sounds like a really trivial problem. Just give me a sample set and a benchmark, and we'll optimize it. And then you go back and you say, well, no, actually, each customer has different risk tolerance, and use cases introduce a lot of uncertainty. You can't just assume that your baseline is going to apply across all these different environments. So, I mean, yeah, Kaggle competitions are they're nice work when you can get it, but they're basically a very constructed, abstracted kind of thing.
Absolutely.
Anyway,
Yeah.
my departure.
It's a good departure, because I think baselines are like hammered home to us as like, oh, you got to test this on a baseline. You got to test it on a
Yeah.
baseline. And then when you're out in the real world building a project, it's like, I don't have access to one. I'm having trouble making one. I have one and it actually doesn't represent my other customers. And when I was working for Twilio, it was back in the old school machine learning days, but we had a lot of different customers and we weren't mixing customer data into one huge pool because there were a lot of legal constraints around that. So we tried to build like AI applications, but you had to have one per customer, and every customer's data was so different because they're different use cases. They're in different like fields and stuff like that. And so we actually encountered that situation live where there was really not one baseline data set to rule them all. And I think it was way more about theoretically thinking about if the model fit the problem and then testing it properly in terms of like a true experimentation framework and production. Like doing those like live tests was really critical.
Right. Yeah. We see that with federal agencies where they
Yeah.
do live tests. They call them bake-offs, but that's really their only, or rather, I should say, it's their best objective measure. So here you've got coverage across the entire lifecycle, and more importantly, like you're saying, is that these measures will follow along as you iterate later on. So you're not just relying on a baseline. I mean, frankly, a baseline is really just an aggregate summary of previous measures and then some kind of descriptive stats. But really, you want those observations to be something that lives with your life cycle and follows along. If I'm catching you.
Absolutely. Yeah, we have this concept of a data set actually throughout the entire Opik system. And a data set it's probably what you're running your baseline experiments on, but it's also something you can add to over time. And I love this because I might have a great data set in the first 2 phases. And then once the thing is in production, I have new people using it and testing it. I might go in and annotate some of those observations and add to that data set. So my data set is kind of growing over time to be like a better representation. And that's all managed in Opik. So I really like that kind of framework here.
So you can add other fields, effectively adding other columns then to an existing data set.
Yes.
Okay, perfect. Okay, so we've got observations, we've got different forms of measure, different categories of what's being measured, and then we've got evaluations off of those observations. The evaluations then are, I guess, in my terminology, coming also from more of a math background, I would say you're building a gradient because you want to be able to optimize at some point. That's one of the goals here. So I kind of look at this through the lens of, okay, I really want some great ways to construct a gradient that's going to be useful, and maybe I'll add to it later on or revise it in some way.
Yeah, let me share a different screen here because you're leading me into my favorite area of AI today.
Okay. I think this is frontier material. To me, this is the most interesting area of AI right now.
I think so. Are my slides showing up here? Maybe not. Let me see. Share screen. Share slides. Can I not share like
You can share. Yeah, you can share. There should be a button down at the bottom in the middle of the tray says present. And so you don't have to upload slides or anything. You can just share your screen if you want.
Are you guys seeing it? Oh, it's just taking a second. There we go. Boom. Okay, technical difficulties. This is what I wanted to show. Okay, so everything I've talked about are really just puzzle pieces. You have a metric to measure things. You're logging your inputs and outputs. That's awesome. It's giving us visibility into our system. It's not improving our system. And the thing I'm most excited about in AI today is feedback loops and more of a live learning and optimization framework for agents. Because a lot of these agents are, at least to me, surprisingly static. I was surprised by how static they are because they don't feel static. When I'm talking to like a chatbot, I'm expecting it to just remember what it learned about me and be able to adapt just because it feels like it has that human component. But unless you explicitly build that in, it does not. And so there's this kind of static nature of these things. They're not improving their prompts. They're not adding to their memory unless you're building that mechanism in. What Opik is doing is we are taking all these puzzle pieces, the tracing, the eval metrics, the experimentation, and we're putting it together in a framework that allows you to run true optimizations, which is going to be a more automatic way to improve your systems. We're starting with prompt optimization, which I think is really interesting. I can zoom in a little bit here to show you this illustration. But essentially, we don't want to go there. We want to go here. Essentially, what you're looking at here is this kind of workflow here. You're coming up with your data set and metrics. We've got that. And then we're picking an optimizer. There's optimization algorithms. You mentioned gradients, things like this from a mathematical background, something we're super familiar with. But it's really just an optimization function. We have a couple different ones here, but essentially it's going to do a gradient descent-ish kind of thing. There's a lot of different optimization algorithms you can choose from here, but essentially it's going to automatically optimize something for you. So that could be tool calling, it could be architecture, it could be the prompt itself. And that's all based on the metric that you choose. So you're defining what you're optimizing for, running that optimization, and then probably coming up with a prompt that is better aligned to your goals that you can now actually measure. I like this a lot because it almost looks like reinforcement learning around an LLM architecture, which I think is very futuristic and maybe we should be thinking about this. But this is a great way to like leverage Opik and really kind of get the extra juice out of this tool beyond just like
Yeah.
making this tool we can have visibility into. We're actually improving it live.
And I love this concept of this feedback loop. You can work with for optimization, but there's both the programmatic component, there's the machines in the loop, there's also the people in the loop. So subject matter experts can go in and, like you say, can change annotations. So you've got people and machines together in a feedback loop. And I'm sure that the folks from more of a defense background will probably recognize an OODA loop, and observe is the first part of that. So sincere.
Yeah, I could see that. I'm a big supporter of human in the loop AI, especially in this phase. I don't think there's a lot of things that we should just like completely automate and not guide or
Yeah.
measure. I think we're in a point where we really need to be collecting human feedback and learning from that. And I think there's a lot of systems where it should be really built as a system that interacts with the human and then optimizes some little pieces over here based on that feedback. So that's a lot of the kind of architecture design that we're supporting here. I don't have like a live demo up because I don't want to do like a sales pitch, but we've got like a cool feedback loop where you can like actually have a human come in and annotate your traces, and then you can add those traces to your data set. So we support like that full workflow.
And we're using this for our tutorials. So if you come to any of the tutorials about GraphRag and entity resolution and all this, you'll see Opik being used. You'll see the dashboard where you're collecting observations, and also where you could go in and add annotations. So I find the flexibility on this is just brilliant.
I'd love to hear a little bit more actually about how you guys are thinking about the entity resolution and the feedback loop in that kind of problem space.
Yeah, the interesting thing, something there is we see large customers, like if you're a bank and you're required to perform due diligence because, like KYC, anti-money laundering, politically exposed persons, there's a lot of different legal reasons why you have to perform some kind of modeling to understand risk. And the problem with the bank is that if you do too much of that, they get in trouble. If they don't do enough, they get in trouble. But there's also some outcomes. Suspicious activity reports get generated, sent off to financial investigation units, et cetera. So how do you get there? And the thing is, we work a lot on that with entity resolution, and why we're really super interested working with Comet, working with Opik, is that customers end up having to do so many experiments. Like maybe you're finding that you're doing merges of different data sets, like you've got your customer database, but then you're buying something from Moody's and Dow Jones and all these other vendors. And you put it together and you're like, we're still getting a lot of like near misses on the addresses. There's a lot of uncertainty. How can we clean up our addresses? And you're like, well, maybe you're paying like the whole system licensing costs of, I'll just throw out a number of like, here's your licensing cost of $500,000 a year. But if you want to juice up the addresses, that'll be another $4 million a year. So
Money, I love it.
yeah, no, the data providers are in a good space.
Good
So I
business
mean,
model.
it is kind of a Parker game. It's like, well, I mean, is this really going to, can we understand how this is going to help optimize us? Can we get measures for
Is it worth the
if we
investment?
yeah, exactly. And
Yeah.
and there's so many variables too, because it might be that you like if you're doing GraphRag, you've got some kind of taxonomy there, probably to help guide how do you extract terms out of your HR documents. What does
Yeah.
that term actually mean? Because you say certain words in front of legal, it means one thing. You say it in front of marketing, it means something else.
Oh yeah.
Um,
Everyone's got their own language.
so can you tighten that down and have that really drive how you're extracting your documents? Because at the end of the day, those documents, like if you go to a big industrial company like ABB, they recently showed using GraphRag to cut their field response time by 40%, which is like, outcomes measured in the billions. And it really does come down to is like, well, should I buy more data to like make this better, or should I tweak my graph, or should I tweak my prompt, or where are all the touch points that I can go in and optimize? So I think that's you're really speaking to the heart of that, is that there are so many levers and knobs, and to be engineers, you have to figure out like, okay, where are the gradients? What's actually making sense?
Yeah. It's interesting because it's almost like the intersection of engineering and maybe statistics or data science or more traditional like analytics, where you kind of have to draw when I approach a problem like that, I have to draw from both backgrounds because I've got like almost a software representation of all of these like levers and knobs, like these parameters, but then I've got to think scientifically about how to actually test that. So if I'm trying to answer a question of like, hey, is it going to be worth it for us to purchase this extra data? I need to estimate some kind of impact. I need to measure that. And that is not easy. I don't have that answer off the top of my head. I actually did some entity resolution at Twilio. It was really, really hard. But
Interesting. Yeah.
the approach there that's really resonated was really going back to like true experiment design and being able to like test and measure things with some statistical significance before moving forward on a decision. And then balancing that with like, I guess this goes back to like kind of my experience in poker, balancing that with a comfort with uncertainty. I find myself like through my whole career kind of developing this like comfort with uncertainty of like at some point, like sometimes we have intuition on things and we can't really pinpoint where that's coming from, but it might be coming from like 10 years of just looking at math equations and just seeing those patterns or looking at data or coding things and seeing what happens in production. And sometimes we just kind of like know, like, is this a good or a bad decision? And that's really a difficult thing to deal with as like an analytical person, because you also don't want to like follow this path of like, I have a hypothesis, I'm going to prove that it's right, and then we're going to go do it. So you have to like still like step back from that, but also like know use that to like lead you to good decisions there.
Right. You don't want to inject your own confirmation bias. But
That's what I'm looking for. Yeah.
I want to come back to that, but I also, Steve Creamer had a question real quick. We'll just get this. And it does look like Steve had to drop, but he had a question. Does Opik support AI models other than LLMs? So like DLMs or computer vision, for example? And are there integrations with knowledge graphs? The second part of it.
Ooh, great question, Steve. Hopefully you'll catch us on the recording. And thank you for joining. Yes, absolutely. So LLMs are just language models, and I guess that's getting a little bit boring. I really am super excited about like multimodal stuff,
Yeah.
voice, image, video. And when we think about like how humans operate in the world, we're using all those sensors. And so the AIs probably should as well. So for that reason, yes, absolutely. We support, especially in our traces, like logging, all those different kind of multimodal data, as well as evals on them. There's been a lot of conversation of like, how do you actually eval audio? How do you eval an image? Stuff like that. So we're working quite a bit in that area. And I actually have a project that I'm working on specifically creating a tutorial on multimodal evals. So that's definitely something that we invest in. On knowledge graphs, I personally have not had the opportunity to work too much with these. I think maybe you've worked with them more than I have. I don't know if we specifically support them, but it's kind of a tough one for me to answer.
Well, I mean, the answer is something we were covering or discussing just a little bit ago. With a graph, what information, what decisions are you using when you're building up a graph or updating data? Like entity resolution is used to determine should two nodes be merged or should they be split because you have new evidence that's just come in. And then there's other decisions like, okay, I use the word consideration. If I'm an attorney, that means one thing. If I'm in marketing, that means something completely different. I can come with a lot of examples of that, but it's basically if I don't get my vocabulary down, like a controlled vocabulary, I need to be able to hone in on that. And if you're working in government, like for instance, have you ever worked with NEAM, the NEAM Information Exchange? So Amber Alert is a good example. If there's a missing child, but they have to go through like tens of thousands of different, there's all the telcos, there's all the law enforcement, local law enforcement, there's also all the local government. When alert goes out regionally, it has to cross through so many different boundaries of organizations. The problem, like the classic problem from 9/11 was interagency information transfer. They dropped critical information because they didn't actually understand the vocabulary. And so NEAM was created in response to that, and it's used by Amber Alert and others. And that's a really good example of like with graphs, it's like, okay, well, we want to make sure we're using the right term here. We're not just linking to something that's a spurious definition because it seemed close.
That's super interesting. Yeah. Okay. Are there specific like knowledge graph tools you guys are using?
Yeah, and there's way too many of those. I mean, I think a lot of discussions about that kind of my caveat would be it gets lost in the weeds because there's like 50 different graph databases, but the real
Okay. I'm really like, hey, am I on the right track there?
Well, I would say that the end use cases, especially the really big use cases, they're very much focused on leveraging the pathing in a graph or graph
Yeah.
algorithms. Like, you know, I think that a lot of the smaller vendors tend to favor, let's use our proprietary query system, which is different than using a graph algorithm. So I'm gonna try to not offend too many people all at once, but I'll say that the use cases are usually more about, machine learning or graph algorithms. And there's a lot of great open source tools. So I love using NetworkX, which is probably the best collection of graph algorithms. And you can use NVIDIA if you want to scale it out with cuGraph. And if you really want a database, you can do that too.
Okay.
It's not going to get in the way. But to your point, it's like, let's do some customer experiments around how we use a particular vocabulary. And maybe we don't need to import that huge, ginormous vocabulary because it's actually causing problems.
Yeah, interesting. Okay. Yeah, in terms of like integrations, we have a lot of integrations, like you
Yes.
mentioned, and we're always building more. So if you guys feel like it would be useful with a specific integration, let us know. We're open source. We have like a issues page where we track everything. Our team builds stuff out for folks very quickly. So if there's
Oh,
something that I think a lot of people use, like let us know. We love that kind of feedback. Yeah,
let me. What's the best way for people to interact and get involved, ask questions?
I like going to our GitHub repo. So I will link this
Okay.
in the chat. So our GitHub repo, it's like a true open source project. There's feature parity with our enterprise version. Like we'll host it for large enterprises, obviously, but I work more with the open source community. And the best way to get in contact with us is to let me just share screen. I'll show you guys the repo itself. Here it is, open. You can submit issues. So going here and just describing an issue, or I hope you don't find a bug. I don't think there's a ton of them actually, but if you do, you can submit a bug. Or if you have like a feature request or something, it can go here. The team is super responsive to this. And another thing you can do is it's a true open source project. So you can contribute as well. And I always tell like early career folks, this is actually a really great way to build your resume. If you actually
Yeah,
want to
absolutely.
or get it submitted to like a tool that's well known like Opik, you're going to work with some really world-class senior engineers that might review your PR. Now you've got a reference for a job in the future. It's such a great way if you're looking for a project to just build that resume out. That's something I did early career that I think really
Oh,
served me.
awesome. This is
Yeah.
brilliant. Well, I will second that. I've actually heard back from people like, they had their PR accepted and they got a job on the basis of like that that pull request.
I love
So
that.
I've
That's such a
definitely
great
heard it.
success story. Yeah.
And also there's the Slack board for OPIC, and I know the developers are on there. It's a great place. People come in real quick and help answer questions.
Yeah, we've got the whole team there. Our product team engineers will respond to you there. Can share the link with it afterwards so you guys can maybe link it
Yeah, we'll
later. We've
put
got
that
like
in.
a whole community in Slack right now. Yeah.
And also, you're going out to a lot of conferences. So there's a lot of definitely presentations, tutorials, also a lot of webinars, and there's a series of reading papers. Is that right?
Yeah, let me link our Luma calendar.
Cool.
We've been doing a cool mix of virtual and in-person events. Let's see, calendar page. Yes, this one here. I'll just link it for the chat.
Okay.
So our events, our kind of strategy here is a mix of in-person and virtual, which means if I'm not on the road, I'm hosting some kind of virtual event. It's a really fun way to connect with everyone. But we do live events. We do a lot of hackathons. We sponsor a lot of hackathons. Again, if you're early career, fantastic way to build your resume, get references, build an actual tool that you can showcase. So we sponsor quite a lot of those, as well as just like talks, conferences. We're trying to stay like very much like in the center of like where people are building, where people are talking about the trends of AI. So we can kind of build alongside you and make sure we're meeting the needs of these projects as they evolve. Because as you know, it's like such a new space. There's like new tools and tech like every day. So it's difficult to keep.
Awesome.
Yeah.
The hackathons would be super valuable for that. And also, I will say that I went to one of your talks at one of these conferences, and I was super impressed. I mean, that was amazing. But also, I've been joining in on some of the paper readings too, and those are really fantastic. There was one this week about Poker Bench,
Yes.
which it's one of the best webinars I've been in a long time. So
Oh, I'm so happy to hear that. That was all the authors. There was this really cool project called Poker Bench where people figured out how to fine tune and to get it to play optimal poker. And poker it's just like the reason it's so relevant for LLMs is it is a very contained problem space that you can define mathematically, but it's also a huge problem space. So the decision tree of it is almost like uncomputationally large. So it becomes a really valuable way to test kind of the limitations of maybe reasoning. I say reasoning with some hesitation of these LLM systems, but it's a really good kind of area for testing that. Similar to like kind of how we were testing AlphaGo with AI earlier.
And it's a problem where there's not perfect information. Like, if
Yes,
everybody showed their hands, you could just figure out who wins. But
a lot
it's
easier.
that's the game, is you don't know.
Yes, yeah, absolutely.
So there is a component of actually understanding the players and like their psychologies, because people are people and they don't always play according to optimal methods. They do other things like bluffing. And it seems like that would be very relevant if you're trying to optimize your supply network or do some sort of a military strategy or others.
Yeah, I think
Investment.
actually, gosh, I'm such a nerd. I read a book about game theory, and it was actually a lot about war strategy and
Yeah.
military strategy. Because in the
Yeah.
end, I think like the concept of game theory lends itself well to any strategic situation. But it is like what you're saying, those incomplete kind of information games. And it's interesting to see now this like newer technology, because game theory is like an old school mathematical approach, like older than ML ops, older, like people are saying like, oh, ML ops is outdated. Well, try game theory. Like that's been around a lot longer. It's just traditional mathematics. And then when we have new technologies like LLMs, it's really interesting to see not just the capabilities, but I think we also need to be super aware of the limitations of the new technologies on solving what I would say are sometimes already solved problems. So it's really interesting to see that kind of like dynamic as we kind of test the limitations of the new tech.
Interesting. Well, I mean, there's so much I'd like to dig in there. I mean, one thing I think we should probably clarify is like in the poker bench discussion, they were talking about using solvers, how to leverage, optimization tools. What kinds of optimization tools do you typically work with? I mean, I know like in Opik there's GEPA and others, but are you using Garobi or other types of solvers?
Oh, interesting. Yeah, the parallel with solve is very interesting here. GEPA is one. I like our few shot Bayesian. It's in our OPIC optimization. So yeah, I mean, going back to like gradient descent and just like iterating, solving things, it's all just like mathematical optimization in the end. And these are the algorithms. So when you're using the OPIC optimizer, maybe you're trying to do like prompt optimization, you have a choice of which algorithm you want to use. And I haven't tinkered too much with like comparing the difference, but here, I'll share screen again. I feel like I always am better at talking through stuff with an illustration.
Yes.
These are the optimization algorithms. So each one has, I think, kind of its pros and cons. If you click into one of them, you'll learn more about that specific approach. And that's something I really like about the documentation is we're not just helping you like use OPIC, but we're also trying to educate you in these kind of like deeper theoretical areas so that you can
Yeah.
make those kind of educated choices of like, well, should I use meta prompt or a few shot? And I think when it comes to like really choosing the algorithm, it is about understanding like exactly what is it doing and is that appropriate for use case? Do you anticipate like any limitations where it might fail based on what you're specifically trying to do? So we have all those. I think that's a whole session just go deep into like how these work.
Oh, certainly. I mean, it's interesting because there's kind of a long-term narrative here. This is very similar to work that was being done, say, with fine-tuning models, where you take
Mhm.
some sort of a foundation model and then you're applying or whatever,
Yeah.
reinforcement learning with human feedback, etc. So you've got that kind of feedback loop there. But then even earlier, talking about earlier work with Rexis and all, there was a lot of work on AutoML, and frankly, this is kind of one of the descendants of, at least it strikes me as one of the descendants of AutoML.
Oh, that's interesting. I kind of forgot about AutoML.
I
Like
know it was like a blip, 6
that
years
was
ago or something.
it. Yeah.
There may be some videos out there of me teaching AutoML at ODSC and other places like that, but I really think that there are a lot of interesting learnings that can probably be applied.
I think so. I never really kind of saw those parallels there, but it is like what we're doing here is like we're moving from like a static agent to a live learning agent. And so you need that feedback loop. You need some kind of metric, some kind of optimization function. So the thing can just like get better over time. And that is super automatic. And so I think it does kind of like put us in that category of somewhat trying to automate some of the like learning of the entire system here.
And you were making an analogy earlier, which I think is super important about reinforcement learning, how much this looks like, the agents that we're developing now look like the agents in reinforcement learning, because there you've got an environment, you've got agents interacting with the environment, there are observations as a loop, there are rewards as a loop. And then, one thing I think that maybe isn't getting articulated in industry right now is like the outcome of reinforcement learning, or rather, let me bounce this off you and see if this makes any
Yeah.
sense. With reinforcement learning, the outcome is not the model, it's a policy. So, you've got something operating in an environment, and when it starts to go off the rails, you want to push it back into some kind of optimal or near optimal envelope,
Yeah.
like aircraft autopilot. And reinforcement learning isn't training a model, it's actually just capturing what's the policy to nudge our system back into better operation.
Yeah.
So it strikes me then that kind of the larger arc for what's going on with observation and optimization with Opik is really literally that, like developing your team's policy about this application.
Absolutely. Yeah. Reinforcement learning is so interesting. I always end up back there. I feel like, well, you attended my talk, I think, at the conference we met at, where I was talking about kind of the mathematics behind AI and the next phases there. There's a lot of like, I think I would call it like design patterns. There's a lot of design patterns that I see in agent architecture that just look a lot like reinforcement learning.
Sure.
And the thing that is so fascinating to me is we're calling it an agent. And if you just look at like the mathematical definition of reinforcement learning, there's literally an agent and a feedback loop. And then you're just learning this, like the output, as you're saying, is the policy, not so much like a model or an AI system. But the design patterns look really similar. And the reason why I think like foundationally this might be like the same is because the basic mathematical definition is the same. You have an agent, which is a thing that can take action in an environment. You can define that environment mathematically, whether that's by a set of actions, a node. In agent architecture, it's probably like tool calling, like you can call this tool or that tool, or you can change your prompt, but you just have these like parameters and actions, and you can always define that mathematically. And once you have the mathematical definition of this environment, now you can optimize in it. Now you can define metrics, whether that's an LLM as a judge metric or like a really exact heuristic metric, but you've got your gradient, you've got a loss function. And I'm probably divulging into a lot of math words now, but to me, like it's really just like defining a contained space and optimizing within that. And that seems to be what we're doing kind of over and over in different contexts.
And another parallel that's important, kind of calling back to what you were mentioning before, is the policy in reinforcement learning. It's got at least two components to it. One of them is effectively the agent's memory, because the agent is collecting like memory of, oh, don't do that, go this other direction instead. And the other thing it's collecting are basically data sets, like annotations on data sets over time that it's learned. So, memory is a little bit more structured and data set has a little different character, but I'd say a policy in RL is really kind of the combination of those two.
Yeah, absolutely. The data set, I think, piece is really interesting there, is collecting the feedback loop in a meaningful way so that you're learning live. Because this all gets back to like kind of like moving from a static system to a live system that can adapt. Yeah.
Interesting. Another thing that, well, let me go on popping back up the stack. But one thing I was going to, you'd mentioned about experimental design, and I was curious if customers are talking with you about how to approach, from more of a statistical standpoint, how to handle statistical design, because you and I both come from stats backgrounds, and it's very rare territory for the people who haven't like spent hours dealing with it.
It is. I feel like we're at like the intersection of two fields, because and like the role definition is like so fuzzy these days. The difference between like a research scientist and a data scientist and engineer, ML engineer, basically like all these folks are just trying to build these systems to get them to work. And I think at this point, it's taking skills from multiple disciplines to get there. We've got to kind of come up with a software architecture that works for an agent. and we've got to code that up following coding best practices and software development, like testing best practices, things like that. But then the LLM itself is this non-deterministic little mathematical model that can go off the rails. And what that actually means is hallucination, which is just a probabilistic function of the math. And what we need to do is statistically sound hypothesis testing. Now, if I'm just coming from a software engineering background, I might not know what on earth I just said. But if I'm coming
Right, yeah.
yeah, obviously you need to do that. So it's starting to kind of like, I feel like the skills to be a really good person who creates an LLM application are drawing from multiple fields right now. So I feel like we're kind of in this space where we all need to kind of learn from each other. I learned how to be a software engineer from the software engineers around me, and they learned how to test their LLM software from my statistical background. So that kind of like collaboration has really, I think, kind of grown into a whole like field of itself that we don't quite know how to name. So to answer your question, yeah, we're all collaborating on this. Like I'm learning how to unit test, they're learning how to do like hypothesis tests, and that's been really valuable.
Interesting. I mean, if you roll the clock back to like, I'll pick a number, circa 2009, people, DJ Patel and other people were floating this idea of data science. The term had been around a little bit earlier, but they were saying, well, you take some stats, some programming, some visualization, some machine learning, put it all together, and you're making decisions for, I don't know, dashboards like what's our week-over-week lift for our advertising platform. But now you're talking about being in this kind of feedback loop of actually dynamic agents live in production and having people who understand the stats so that we can go in and probe this in a way that's reproducible, working alongside the people who understand how to like dig into PyTorch if something's really gone awry in the model, right? There's disciplines that probably go a lot deeper than, say, the sort of almost commodified version of data science that it is now. There's something new evolving.
There is something new evolving. That's something I've been thinking about actually recently, because there's these like new titles and roles like developer, LLM engineer, AI researcher. What is that? It's what I call myself, but what is it? I don't know. It's whatever I'm working on today. I don't know. But I feel like it makes job searching very difficult. And I think it makes hiring very difficult. Like if you're trying to build a team to build LLM apps, what do you put on the job description? Figuring that out, I think, in a moving space where we're still kind of developing the tools and tech is very difficult.
Yeah, I had a friend who was working for, how should we say, it was a consultancy for like recruiting firms, but the whole job was just going and pulling in all kinds of job descriptions and then understanding them and building up stats around like what works, what doesn't work.
So interesting. Yeah.
And LinkedIn, for friends who build a graph at LinkedIn, they spend their days trying to align all the user definitions of job titles and make sense of it.
It's probably really complex. Yeah.
It's like I've heard numbers of like, tens of thousands or hundreds of thousands of variations in engineering, but then like a tiny little variation if you're a nurse, and really what's more important. But yeah, it's a very imbalanced moment. And I was going to ask you, actually, that brings to mind, you had a post about kind of the dangers of trying to have too many neologisms in your title, like, coming up with the title du jour. And stop me, I may not be paraphrasing this correctly, but I really appreciate what you're saying. It was like toward the year end about how, just kind of do your stuff and don't worry about how you name what you are.
Yeah, job titles are noisy. I know what post you're talking about. I'm always posting thought pieces on LinkedIn because I just get such good discussion, learn so much from people in the comments. But yeah, I posted something kind of about like job titles are noisy. And I think specifically for like the field of AI, that's very, very true. It resonates with a lot of folks because the field is not where it's going to be at right now. I think it's going to change so much. We're still innovating. I see some technologies that look very futuristic. I see some technologies that look like a Band-Aid that we probably won't need once we figure out some other stuff. So it's such a moving space, and it's really hard to know what to learn and also like what to call yourself. Are you a software developer? Are you AI researcher? Are you just a developer using AI? And I think it also like it can get into like imposter syndrome because now we're talking about what we call ourselves and what that means. And do we really feel up for the job in this like moving space where we don't know all the technologies because it's impossible to learn all of them. So the advice that I really give to people in that position, because I'm in the same position, is just ignore the title. I know it like feels pretty cool to
Yeah,
be called a this or a that or a senior this and that, but
sure.
in the end, what are you doing? Do you love it? What are the skill sets that you need to do that task? And are you continuing to like learn and grow? I think that's really what it comes down to. And I think that we're a little bit over indexing on like people are like, okay, it's like the LLM engineer, LLM developer. Well, everyone kind of defines that one differently. And if I went out and looked for a job for that role today, I think I would be interviewing for a lot of actually very different positions. And how do you prepare for that? So just look at the job description and like, does it look like something you love and go based on that.
Well, very, very good advice. And going back to the notion of observability and evaluation, it's interesting because the industry's feedback loop has some terrible latency. Like a new
Yes.
technology will get introduced. It'll like for deep learning, it took 6 years before AlexNet had the data set to show that the deep learning paper actually made sense. And then it took how many years before enough enterprise firms hired up people with the right talent? And then legal prevented them from publishing for another 2 years. So you literally get this thing where like Silicon Valley will declare some technology dead, and the industry analysts are all posting about that. And then 2 years later, AstraZeneca will say, "Oh yeah, we're using that. We have huge revenue. We couldn't talk about it before." So I mean, I think that if you're just like trying to define yourself based off of the latest thing that some pundit said on a post, then you're gonna get hit with that latency.
Yeah, and it's a scary place to be, honestly, because you don't want to like brand yourself as some role and then that role becomes like obsolete or something. So
Yeah.
I think the key, like it actually goes back to our earlier conversation, is we're seeing the same design patterns
Yeah.
in the big data craze, in the internet craze, which was before my time, but I'm seeing a lot of the same stuff, like in terms of how we manage the projects. It all really kind of comes back to these agile principles. And in terms of the technology, it's like there's core best practices for software design and there's some core mathematics that will give you the intuition to know if this model is appropriate, inappropriate for the task, and how to measure that. And those skills are not going anywhere. So if you understand the math, if you understand how to just code well and follow best practices, you're going to be able to take like a new technology like LLMs and kind of have this like intuition on like how you should and shouldn't build around it. Like the concept of observability itself existed before LLMs. Now we're applying it to LMs, but if you already knew it, like it'd probably be like kind of intuitive of like, yeah, we should measure this and debug here and that kind of thing. So those foundational skills I think are the key here.
So like, I mean, we could go back to like New Relic or Datadog or other
Debug,
things that
yeah.
have been doing, observability for a long time, but it's there are practices. And if you
Yeah.
don't follow the practices, those who forget the past are doomed to recreate it.
If you don't
Um,
follow the practices, you will after something goes wrong. That was my experience.
yeah, that's even better. Well, wonderful.
Directions about observability. See what happens. You'll use it on the next one.
Well, I know
Yeah.
we're coming up on time, but I have one more question. I was just curious, like, what's on the horizon as far as conferences? Where are you and your team heading out to? Where can people
Oh
go?
yeah. Let's see. Check out the Luma calendar for
Okay.
upcoming live events. We have a lot of virtual planned. We always have a presence in the Bay Area. We're always sponsoring hackathons. We have a current hackathon ongoing called Encode that is virtual, so you can participate from everywhere in the world. I don't know where I'm headed next. I'm kind of focused on like virtual content right now, so I'll let you guys know. Yeah.
Well, thank you very much, Claire. Really appreciate so much wisdom here. So many things very well said. And I love what you all are doing with Opik and look forward to doing much more work with you all in the future.
Yeah, fantastic. Thanks for using our tool and then giving me this opportunity just to yap about things I'm really passionate about. It was really good to chat with you.
Thank you much.
All right.